Today you are going to be working with, hello, voices are off. Today you are going to be identifying angles. Working with specifically vertical and adjacent angles. For the most part, you are going to be deconstructing angles like we've done in previous work. Only now you're going to be talking about your vertical and adjacent angles. So if you start out just by identifying these four angles that are on your paper. Just identify the types of angles you have there. Were there any of those blue book things left over?
No.
Okay. And everybody got one? Okay, so we didn't have.
No, it's these.
That I got. That I got.
Here. I have mine. You gave
Okay.
me mine and Alice's, but you didn't.
The assignment on the Fair Game Review, we're going to go ahead and just turn that into the drawer because I want to look at it myself. I seen several of them were over there, but I want to see what you did. Michaela, what do you need, babe?
I have Alice's stuff.
Okay. We got it now. How many of you were pleased with your test results? That's what I thought. And it did really well for boosting grades at the end of the quarter, right? Well, this, in my opinion, this chapter is going to do the same, only it's going to give you a strong start, okay? Because it's more of the same type of stuff. Today we are simply identifying adjacent and vertical angles. Let me get this written. All right. Number one, what type of an angle is number one? Somebody raise your hand and tell me. Kenai.
Right.
This one is a right angle. You didn't need to measure it, did you, Kenai? Nope. How do you know it's a right angle? What told you that?
90 degrees.
90 degrees and that little symbol right there, okay? Knowing that it's a right angle and knowing what that symbol stands for. Number two, what type of an angle is it? Reagan. Obtuse. Why is it an obtuse angle, Reagan? It's greater than 90 degrees. Good. What about number three? Trenton?
Acute.
Acute. How do you know it?
It's less than 90 degrees.
Less than 90 degrees. What about number four? Is it going to trip you up? What type of an angle is number four? What type there, Jabin?
A straight angle.
How do you know it's a straight angle?
Because it measures 180 degrees.
Good. It would measure 180 degrees. Simply review. Now, in talking about vertical and adjacent, this should be familiar territory to you. Okay? An adjacent angle is when they share a common side and the vertex. So it has to have a side and the vertex. So if you look here at angles 1 and 2, on this drawing, angles 1 and 2 share that side. That's what makes them adjacent to each other. Okay? Kennedy is adjacent to Caitlin. They share that one side there where their desks meet. Okay? They are adjacent to each other. All right? Vertical angles. Another thing about adjacent angles, if you look especially at these two, you can see what type of lines there that are connecting. What kind of a line does the sharing of that one create? You got a straight angle, okay, or a straight line, okay? Vertical angles are two angles where the verticals, they share the vertex, but they do not share either side, okay? They share the vertex. Two angles are vertical angles when they are opposite angles formed by the intersection of the two lines. They are also congruent. That's the beauty of the vertical angle. They will be the same. Congruent means the same or equivalent. Okay? Any questions about that part? So if I was to look at our desks here are not set up to where we have vertical angles at all, are they? No, they're not. And the other thing I like to say is the vertical angles are looking at each other. Okay? I like to say that they look at each other. They're face to face. Adjacent, you have to turn your head to look at somebody that's adjacent to you. When we have our desks in a square, usually we have vertical angles with those. All right, let's just take a look at it. We know what they are. You have this. I want somebody to name a pair of adjacent angles that's being shown here. Name a pair of adjacent angles. Adjacent angles share a side and a vertice. So give me a pair of adjacent angles. Yeah, brain just went. Page. Do what? Okay, you've got to give three, in order to name an angle, you've got to give 3 points. So, tell me again. Okay, we've got FBE, angle FBE, and what is it adjacent to? FBE is nothing more than this angle right here, okay? What angle is adjacent to that one? They have to share the vertex and a side. So AB, where's the side they share? ABF, good. Notice the symbol that I'm using so that I don't have to write out the word angle. Because these angles do not have a numerical number like the sample in the explanations, these angles, these 1, 2, 3, and 4 are saying angle 1, angle 2, angle 3, angle 4. They've identified it by the numerical number right there. In the ones that we're working with right now, they haven't numbered the angles, so you have to give the 3 points. Okay? Give me another set of adjacent angles that you can find. Jillian. Angle ABD and angle, what'd you say? You said EBD? And what angle? And DBC. I agree with that. Because now she's looking at EBD, which is here, EBD, and DBC. She's saying these two are now adjacent. Okay? Are there any others? Any others there? Zane.
ABF and ABC.
Angle ABF. And what's your other one?
ABC.
And angle ABC. Good. Did we have all of them now? Or is there anything else? Have we got all of them? Wesley, do we have all of them?
I was gonna say DBC and FBA.
DBC and FBA? Well, DBC's here. What side would they be sharing if that was a true statement?
D.
D's not a side. D is just a point. Do you agree? You said DBC, right? Here's what I heard you say. Angle DBC, and what was the other one you said? FBA. When I look at that, I know instantly that would not be true. Because two of these letters have to be the same. If you look at it, FBE, ABF. So the BF, notice right here. Here we've got EBD. See the same side? Over here we've got the same side here and the same side there. Do we agree? Do I have anything in those two that is the same? Other than the vertex. So this would not be adjacent angle. Okay? Go try though. Michaela. Angle ABD. Oop, that D looks like a P. That's terrible. And angle, say it again. ABC. Okay. ABD. Something's wrong with that one. Would they be classified at, let's see, they would be ABD is a straight angle, is it not? And ABC, well, technically, it would technically be adjacent angles because what angle are they sharing, or what side are they sharing? AB. So technically, yes, that is correct. AB and AB. Okay? So you see there are several there. What about vertical angles now? Let's look at, what do we know they have to share? What do vertical angles have? By definition, how do we know if they're vertical or not? And your definition's on your papers if you don't remember it. By definition, how do you know they're going to be vertical? How do you know it, Zane?
They share a vertex.
They have to share the vertices. Okay, so they have to share the vertex, and there's something else about it. And they have to be, nope, not adjacent. They have to be what, Aaron?
What you said, facing?
Facing each other, or we call it, you can look at the definition. It's okay, you got it. They're going to be equal. They're going to be, look at the word, vertex, angle, wait a minute, vertical angles which they are opposite. So they have to be opposite each other and share the vertices. So with that information, which ones, I'm going to erase this, which ones are vertical angles? Aaron. Angle F, B, E, and angle A, B, C. So I've got this angle and this angle. They are opposite each other. Okay? Opposite and congruent. Okay, Zane.
FBD and ABC.
FBD and ABC.
Yep.
Yep, I agree with that. Let's see if I can get a different, another color. So we're saying FBD.
Yeah.
And ABC. Okay? Okay. What do you see, Matthew?
Okay, I don't know. ABF and DBC.
Angle ABF and angle, what was your other one?
DBC.
DBC. Good. Notice how they're pretty easy to pick out. There's several of those. Okay? And if it want, now, this just asked me to name 8 there. So all I really technically had to do is name one. Okay? but we've kind of done some practicing with it. All right, you have your own paper. Name 2 pairs of adjacent angles and 2 pairs of vertical for both 1 and 2. 2 pairs of each. So start with your adjacent. Put an ADJ above it, and then you'll know what you got there. What side do they share? W's and they don't even share that. So if you go with your what angle is adjacent? They do not share a side, they have to share a side. So ZW what? ZW Y. Because they would share that part. Okay, so we need to listen to you. Make sure you use the symbol for angle, otherwise you just got a bunch of letters there on your paper that mean nothing. Got it. I see it. Somebody give me an adjacent angle for number 1. What's a pair of adjacent angles? Let's try this, Miss Savannah. Angle Z, VW. Uh-huh. And angle VWX. I would agree with that. Okay? And the reason I know it has to be is because you've got VW here and you have VW there. Okay? All right, what's another pair of adjacent angles in number 1? Give me another pair of adjacent angles. Give me a set of adjacent angles.
So you wrote the first angle wrong. It's VWB, not VW. It's still right. It's just
Yeah, I agree. Put your vertex in the center, okay? ZWB. Okay, Savannah? All right, give me another set, Miss Zoe says XWY, okay. And what? XWY and XWV. Good. Angle XWV. Good. What about a vertical angle? A pair of vertical angles. Give me a pair of vertical angles, Trenton.
VWY and XWZ.
Okay. VWY is a straight line, straight angle, and XWZ is a straight angle. No. Typically we wouldn't say those are opposite each other, but yet they are opposite straight angles. I've never seen anybody use that as a set of vertical angles though, and I need to double check whether that's even possible. Okay? I've never seen it used that way, and so I'm thinking there's a reason why not. Okay, and I'll look that up for you. But with that being said, can you give me another pair? Because you had to have two. Emily, help him out.
Angle VWX and angle ZWY.
VWX, ZWY, yes. Okay. One more set for number one. Another set of vertical angles. What's another set of vertical angles there in number one? Kennedy.
VWX and VWZ.
VWX. VWZ would be adjacent, not vertical. Okay? What about VWZ and angle XWY? Would they be classified as vertical? Yes. Okay? Finding vertical and adjacent angles. Fist of 5. Can you identify vertical and adjacent angles? Okay. What about number 2? What about number 2? Give me a set of adjacent angles in number 2. Give me a set of adjacent angles. NJP and angle PJQ. We need to start calling it as they are instead of just naming the letters. So angle NJP and angle PJQ. Yes, they share the PJ or the JP, whichever you want to call it. What about a vertical set of angles? Give me a vertical pair. Jillian?
Angle MJL and angle PJQ.
Okay, so you said MJL, which is here, and angle PJQ, which is there. I agree. Okay? Would angle KJL and angle PJN be vertical angles? Are angles KJL and PJN vertical angles? Give me thumbs up if you say yes, thumbs down if you think no. Showdown, folks. Angle KJL vertical to angle PJN. Thumbs up or thumbs down? Good. Should be thumbs up because this one is going to be vertical to this one. The lines there is also saying, because they're both the same, they are congruent. They are equal to each other. Okay? The thing is, if I knew that angle PJQ and angle MJL were vertical, and I knew these two were vertical, could I find the value, and I knew their measurements, could I find the missing measurement here, NJM? Could I find it if I knew the other two? I sure could. Because I would know that I have a straight line here, and so these two plus that one would have to equal 180 degrees. And that's how we're gonna be using this knowledge of vertical and adjacent, okay? We're gonna to apply it, not necessarily today, but a little bit. Tell whether the angles are adjacent or vertical, then find the value of x. Well, what do we got here? With these two angles that they have marked on number 1 there, are they vertical or adjacent? They're vertical. They're vertical. So what do you know about vertical? What's the measurement of x? What's its measurement? 70 degrees. Good job. Because by definition, adjacent angles are congruent. Okay? So look at the second one. If I know that altogether those two angles create a 90-degree angle, and if I know that one of them is 31 degrees, can I identify the missing angle? I can, and can I also then identify the value of x? Okay? Somebody tell me how they want to do it. How do you want to do it, sir?
I put 90 minus 31 degrees equals x plus 4.
But does it equal x plus 4? 90 minus 31? Shouldn't it? That would be one way. Okay. What's the value of x? What is the value of the missing measurement? What's its value, Sophia?
55.
Sophia says x is 55. Is she correct? 55 plus 4 is 59. And 90 minus 31 is 59. So that is a true statement. It does check, and the value of x is 55. Okay? Taking what we know and solving for the unknown. Is that not what we do in algebra all the time? Yeah. Look at this one. Now you have to draw a pair of vertical angles. You have to draw a pair with a measure of 40 degrees. How are you going to do it? You just thought you were done measuring.
Yeah.
Okay, I got that much. I go to my have two vertical 40-degree angles? Yeah. So is drawing them gonna be tough for you? Because this one is now 40, and this one is now 40, and they are vertical. Okay? Are they opposite each other? If you would extend one of those lines, it might work for you, bub. Let's see. No, they're not. No. If you bring this one on down, this here would be. Look at this. You take this right here, extend it, extend it. Okay? Now then, if this one measures 40, did it? This is the one you measured. Then this one here has to agree. Put it here. Does it measure 40? Yeah. You see, these two are your vertical.
Okay.
These two are not. Okay? Okay. Okay, then borrow somebody's because I'm not going to give you another one. Okay. All right. Does everybody got two vertical? Do they have a pair of vertical lines that are 40 degrees? Those are not vertical. These two are not vertical. These two are vertical. Yes. We would extend this one. If this is your vertical angle, your 40 degree, which one did you measure? You measured this one. If you extend these two lines, then you would have your vertical. This is not a vertical to this one. These two are vertical. There, if you've got one at 40, okay, may I see something here real quick? Did you measure this one to be 40 degrees? Then extend the line, see your pencil. All you have to do is extend into both directions. Okay, and using this same line, just make it longer. These two would be vertical. Okay, because this is just nothing more than an extension of the original line. So these two are vertical. Okay? Good. The way it looks, I would say no, because you got a couple of different things going on. Two vertical the vertical angles are going to be an extension of each other, and yours is not. You've done something extra to get to 40, so those are not vertical. These are vertical. Vertical, vertical. Those will be vertical. Yes. All right, so draw a pair of vertical. We're good there. Let's find out what we know. Let's go there. Tell whether the angles are adjacent or vertical and find the value of x. Number 3, are they adjacent or are they vertical? How many people say they're adjacent? Thumbs up? Okay, I agree. What is the measure of x? How do you know that this is what I heard was 95. How do you know that? Defend that for me, Caden.
Because that angle has the measure of 180, and so if you add them together, they equal 180.
Right, I have a straight line, so that has to be 180 degrees. And so to check that, the 85 plus 95 has to also equal 180 degrees. Absolutely correct. What about number 4? Raise your hand and tell me whether they're vertical or adjacent. Yes, sir. Cooper says vertical, so that means what with x?
Wait,
X has to be what measurement?
the same.
Say it, you had it. 90 degrees, absolutely correct. These two are vertical. These two are adjacent. What about number 5? Are they vertical or adjacent? And find the value of x, because that's what it asks for. Alice.
Adjacent.
Adjacent,
Yeah.
okay.
And then, wait, me to continue?
Mhm.
34 degrees.
X equals 34. And how do you know it's 34?
69 minus 1 is 68, divided by 2 is 34.
So you said 69 minus 1 gives you 68 divided by 2 equals 34, okay? So if we,
Sorry, I subtracted before I did that, so if
It'd be 90 minus 68.
I got x equals 10.
Yeah, I got 10. I got 10. X times 10 times
Yeah,
20.
it's 10.
is it 10?
Yeah.
Yeah, I was sitting here, okay. And when you got x equals 10, folks, what was the equation that you put together? What equation did you start with? Because that's gonna be the kicker. You have to know how to write it.
Yeah,
Oh, okay, folks, stop. Freeze. Give me an equation and tell me how you know it. Jillian,
90 minus 69, which is 21. You would
Okay.
have to do the opposite of subtraction, which would be addition. So you would add the 1 to it, and then you divide it by 2. Because if you put 11 into that, it would be 2 times 11, which is 22, minus 1, which is 21, and then you would add that to 69, which would be 90.
okay? Why didn't you just set up an equation that looked like this?
That's how I would do it in my head. Sorry, but like.
Is that gonna work though? 90 minus the 69 has to be equal to the 2x minus 1? Will that work?
Yeah.
Aaron?
Okay, so if you 11, because if you do 2, stop.
Okay, hang on a minute, Aaron, because there's someone talking here next to you. I can't hear you. Okay, try again, Aaron.
It's 11 because if you put it together, it's 2 times 11 minus 1. You get 21, and then you do 69 plus 21. That should equal 90.
Yeah,
Okay.
11
Because if you
What's 90 minus 69?
21.
21.
Cooper. Okay, so what's 90 minus 69?
just check
21.
21. What is 2 times 10?
20.
Minus 1.
19.
19 is not
So
equal
what's
to
19
21.
plus 69 then, Cooper? If that was the true, what is 19 plus 69? Yeah, and I gotta have it equal 90, so that won't work, bud. Okay? Hang on a minute. Can we have our voices off for just a second? Olivia?
So it's 90 degrees, and so 69 plus 2x minus 1, and then you multiply it into the negatives, and so 69 minus 1 is 68, and then you do the subtract it, and then I subtract by 68 is, or whatever it is, 22 divided by 2 is 11.
And that would be the other way to have solved it, the other equation. I agree. Did I write it? Yeah, 69 plus 2x minus 1 would have to equal 90. So there's 2 possible equations. Okay? I'm not doing the next one. We're moving on. Okay, what do you know? Let's find out. True or false? Thumbs up, true. Thumbs down, false. Vertical angles are always acute. True or false? I don't want mouths. I want to see. Everybody's answering. Vertical angles are always acute. That is a false statement. Adjacent angles could be acute. If they're adjacent, could they be acute? Yes or no? True or false? Everybody's got to vote. Don't be looking at other people. Vote for yourself. True. Adjacent angles could be obtuse. True or false? Could adjacent angles be obtuse? I got some that aren't voting. Are you not voting because you don't know? Or because you just don't want to vote? It is true. Because adjacent angle or a obtuse has to be larger than 90. So I could have a 91 and a 100-degree angle together.
Yeah, a number
And
2
that
is
would-
95 and 85, so it could be acute and obtuse.
Okay. Number 4, vertical angles are congruent. True or false? Everybody should know the answer to this one. We've talked about it a lot. True or false? Thumbs up. That is true, by definition. Adjacent angles could be congruent. Could be. True or false? We got a split on this one. Think about this. If I had a straight line, if this is A, B, C, is it adjacent to CBD? Are these two angles adjacent to each other?
Yes.
Could they be congruent?
Yes.
They could both be a 90-degree angle, couldn't they?
Yeah.
So this would also have to be true. They could be. The word meaning, the word that's operative there is could. Not that they always will be, but it's possible. Okay? There is your assignment. You're working in your supplement here. This is what we're going to be working with for a while. You do not have to bring the big textbook yet. We'll be working with this for a while.